now look at implementations of these primitives on the power architecture. And although we will use a power 8, I don't have exact measurements of how many clock cycles these synchronization instructions take. And it's not so trivial to make them. It's quite a lot of work. And the measurements done at IBM Research by Christoph von Praun, they were done for power 4 and power 8. But these are not exact numbers that every, for instance, heavyweight sync takes 140 clock cycles on the power 4 and 50 on the power 5. Instead, they depend on what is actually happening in the machine. But what we can see is that the trend, firstly, is that the newer versions, if we assume this holds, which I believe is the case, they make these instructions more efficient. And also they take a lot of time. So we don't want to do lots of synchronization instructions. Okay, so let's look at what they do. First, recall load and reserve and store conditional. I have mentioned this before, but just repeat it here. Some CPUs, they have atomic test and set instructions, and others, including ARM, MIPS and Power, use 2 instructions instead, and we will see how that can be done in assembler code. By this load and reserve and store conditional. Okay, so how does this work? Well, the load and reserve, it makes a reservation of a memory location in memory, and then if a different CPU writes to that memory location before the first CPU did the store conditional, that reservation is removed. And the effect of that is that the store conditional fails, and that the CPU will notice, and the programmer hopefully has put this in a loop that continues until the store succeeds. And the effect of that is that we will get the read, modify, write. So the store instruction looks like this. Store word conditional, with X being that the address is the sum of 2 registers, and conditional, well, it's already in the C, but as a convention, an instruction which ends with a dot sets the condition code in this CPU, so that it can be tested on a conditional branch later. Okay, so the synchronization instructions for power, they are called memory barrier instructions. And a memory barrier instruction, they have 2 sets of other instructions, namely the set of instructions which executes before the barrier and the set of instructions that execute after the barrier. And depending on which barrier instruction that is used, certain reordering between instructions from the A or B sets is allowed. A is the set before the barrier and B the set after the barrier. So the most costly synchronization instruction is the heavyweight sync, and it permits no ordering of instructions from, no instruction from the A set may move into the B set and none from the B set may move into the A set. They are not allowed to be reordered in any way. Okay, so to do a sequentially consistent write on the power, then we need to use this. So this hurts to read. Say we use the sequential consistency, and every such write that we do in the middle of a critical section would on a power 4 take in average 140 clock cycles. That's painful to know. Or 50 clock cycles. Okay. So it's the if we use this memory ordering, the compiler will produce this, obviously. Okay. A lightweight sync. It can be used for a release, and all the well, these instructions are ordered, meaning that in particular that no store after the load, after the lightweight sync is allowed to move to before the sync. So if we modify some shared data with just normal store instructions, this means store word X is that the address that should be modified is the sum of these two registers, and we want to store the data in register 1. I will obviously not ask anything about that on the exam, but this is just to explain the syntax of this assembly program. But the idea of having this lightweight sync and why it's useful for a release, that is part of the course, but not the exact syntax of a store instruction. Okay, concepts and principles are important, but not syntax details for something that is not so important. What did I say? The syntax of power is of course very important, but not in this course. Okay, so what we do is to perform the writes. Then this lightweight sync will make sure that these have completed before we can set a flag to free. Okay.